7 then, we're being asked to complete the expansion of 1 minus 2x to the power of 5. Now it says using the binomial expansion or otherwise in the question. So you can do this in other methods, but the quickest way is to use the binomial formula. So the binomial formula is 1 minus 2x to the 5. So the first term is a to the n. So just if you need to, just write out that your a is 1 and that your b is minus 2x. And n in this case is 5. So the first term is a to the n, so 1 to the power of 5. So that's the 1 that they've got there. The second term is 5 choose 1, and we'll look at how we do that on our calculator in a minute. A to the n minus 1, so 1 to the power of on top of the 1 is decreased by 1 each time, so to the power of 4, and b, so times by minus 2x, or minus 2x to the power of 1. We then want so that will give us our p term, so that's effectively what p is equal to. The next term, 5 choose 2, 1 to the power of 3, and minus 2x, and that one is squared. That's going to give us our q term, and then 5 choose 3, 1 to the power of 2, minus 2x to the power of 3, and that's going to equal r. Now, what some students then did was continue this to find 80 and minus 32, but they're given in our question, so we don't really need to do that. All we need to do is evaluate these three that we've found here. Notice that the powers all add up to 5, which is our quick check that we're probably on the right lines. So into our calculator then, we're doing 5 choose 1, so it's 5 shift divide button to give us the choose symbol 1. That's being multiplied by 1 to the power of 4, and that's being multiplied by, and in brackets, minus 2x to the power of 1. So the only thing I can't put into my calculator here is the x term. Just got to remember that I'm doing that. What might be better is to actually take your time with this and write this out in full. So 5 choose 1, which comes to 5 times by 1 times by minus 2x. And that's going to give me minus 10x. And I can go back to my calculator and just check that that's the case, minus 10. And then with the x term there. We're then going to do the same thing, so 5 choose 2, and if you set your calculator up like this, as I say, you're not really doing your full exam workings, but what you are able to do is just go back in and edit what you need to make this a really quick process. So the final solution is going to be 40x squared. And again, just for completeness really, I'm going to make sure that I've shown this fully. So 5 choose 2, which comes to 10, times by 1 times by minus 2 squared, which is 4x squared, positive 4 there. The final one is going to be 5 choose 3, so again going back in and editing this formula. 5 choose 3 is now 1 to the power of 2 and minus 2 to the power of 3, which gives me minus 80. So it's going to be minus 80 x cubed. And again, I've been a bit lazy and I really should come through and complete this. So it's going to be times by 1 times by minus 8 x cubed, and 5 choose 3 is equal to 10. Okay, and if we needed to check that, we could just do 5 choose 3 on our calculator and find out that it is 10 there. So we can see that these are our 3 terms in that binomial expansion. I think for the basis of part B, if nothing else, it's worth just writing it out in full. Some students tend to write that P equals minus 10x, Q equals 40, and R equals minus 80, which is what the exam mark scheme looks like. But if we just write out in full, then 1 minus 10x plus 40x squared minus 80x cubed plus 80x to the 4 minus 32x to the 5. And as I say, there's no need for us to actually calculate these two terms using the formula. We were just wasting time if we do that. So we're now going to use what we've found for part A in part B. Okay, so I've put what we've found as a result from part A up here, and we're now on to part B. So it says find the exact value of the x to the 10 coefficient of x to the 10 in the expansion of 1 minus 2x to the 5, which is what we've got already, times by 2 plus x to the 7. So what we need to think about is when we have this expansion that we've got here, how are we going to get x to the 10 coefficients? Where are they going to come from? So looking at it, we are going to have this term here. So we've got all of this being multiplied by the expansion of 2 plus x to the 7. So this term here, we need to know what the x to the 5 term is, because x to the 5 times x to the 5 would give us x to the 10. So there's going to be some unknown there. We're also going to be multiplying by this term, x to the 4. Well, that's going to be times by x to the 6. So we're going to have some b number of x to the 6's. And finally, we've got our x to the 3, so we need to know what the x to the 7 coefficient is, because x to the 3 times x to the 7 gives me x to the 10. So I need to know these three coefficients from 2 plus x to the 7, and once I know those three terms, I'm going to be able to work out what I'm multiplying minus 80 by, plus 80 by, and minus 32 by. Okay, so to work out the x to the 7 coefficient then, we want the x to the 7 coefficient in the expansion of 2 plus x to the 7. Okay, so in this case, a is equal to 2, b is equal to x, and n is equal to 7. So the fastest way to do this is to consider this generic format for a term in a binomial expansion. So the x to the 7 term is going to be given by 7 choose. Now what do we want? We want x to the, we're going to have 2 to the power of something, and we're going to have x to the power of something. Okay, there's going to be 2 powers instead of those boxes, and in our choose there's going to be a term or a number there. So if I just remove those boxes, we want x to the 7. Now we know that the power on the 2 and the power on the x have to add up to the power to the value of n, so this is going to have to be 0. And looking at this, the power on b, the r, is the same as the r there, so it's 7 choose 7, 0, 2 to the power of 0, x to the 7. Okay, now 7 choose 7 comes to 1, anything to the power of 0 comes to 1, x to the 7. So quite straightforward, the x to the 7 term is just, the coefficient is just 1. We then want to know the x to the 6 term, because that's what we're going to be timesing by the 80. So 7 choose 6, getting ahead of myself there. So we know it's going to be x to the 6. The 2 powers need to add up to 7, so it's going to be 2 to the 1. So 7 choose 6, 2 to the 1. Oops, sorry. 7 choose 6, which is 7, times 2 to the 1, which is 2, times x to the 6. So we've got 14 x to the 6's. And then the final one, just give myself a bit more space, 7 choose 5. I've got 2x, and if you've spotted the pattern here, we want x to the 5, which is where I got the 5 from down here. 5 plus what is 7? 5 plus 2 is 7. So I'm going to be doing 7 choose 5. Oops. Just go back in there. 7 choose 5 is 21, times by 2 squared, which is 4, times by x to the 5. So 21 times by 4 is 84 x to the 5. So we haven't yet finished. This is the reason why this is 5 marks worth of working here. So the 1x to the 7 is going to be multiplied by, so that's that bit there, is going to be multiplied by minus 80 x to the 3. Okay, my 14 x to the 6 is going to be multiplied by plus 80 x to the 4. And my 84x to the 5 from here is going to be multiplied by minus 32x to the 5. Now, that's all the ways in which, from the expansion of x to the 7 and the expansion of 2 plus x to the 7 and the expansion of 1 minus 2x to the 5, I can get an x to the 10 term. I can't get an x to the 10 term out of this one, 40x squared, because I would need to be timesing that by an x to the 8 term, which doesn't exist. So these are the three ways in which I can get my x to the 10 term. And each of these is going to be added together. So I've got 1 times minus 80, so I've got minus 80 x to the 10. I've got 14 times 80, so 14 times by 80, they're both positive, so it's going to be a positive solution of 1120 x to the 10s. And I've got 84 times by minus 32, which is minus 2688 x to the 10 again. Now with a binomial expansion, they are then added together. So I'm going to add together my three terms, minus 80 plus 1120 minus 2688, which comes to minus 1648 x to the 10. And there is our x to the 10 coefficient for that double bracket expansion. So just to review what we've done then, we have thought about 1 minus 2x to the 5 and written that out fully. We then think, where are we going to get x to the 10 terms from? And there's three of them. X to the 3 times x to the 7, x to the 4 times x to the 6, and x to the 5 times x to the 5. So we work out what the x to the 7, x to the 6, and x to the 5 coefficients are in the expansion of 2 plus x to the 7, and then complete our multiplication to find our final solution.